So looking at special grade triangles, to be completely honest, special grade triangles don't really have much of an application with just themselves. We use them as a tool to help us with another application. So first of all, we need to be familiar with what they are. There's two types of special triangles. First, the 45, 45, 90. Talk about it in terms of its angles. 45, 45, 90, it's an isosceles triangle. So it will have two sides, the two legs, that are the same length. They'll be x. Might be 5 and 5, might be 12 and 12, but they'll be the same length. The third side, the hypotenuse, will be different, and it'll be x root 2. So if these two sides were 5, this side will be 5 root 2. If these sides are 12, this side would be 12 root 2. It's just a simple relationship that exists between the sides of that 45, 45, 90 triangle. What's important now is that you know and you can remember the side relationships. Likewise, we've got another special triangle, the 30, 60, 90 triangle. It's not an isosceles triangle. It's scalene, so all three sides will be different lengths. The shortest side, I'm going to call it the short leg, will be x. The hypotenuse is always double that, so 2x. And the middle length side, or the long leg, would be x root 3. So, for example, if this short side was 5, the hypotenuse would then be 10, and the other leg would be 5 root 3. Again, not important how we're going to use this yet. What is important is that you remember the side relationships between these three sides. So before we actually get into using the special triangles, we've got to take a look back at some grade 10 trig. We've got three primary trig functions. We've got sine of theta, opposite over hypotenuse. Cosine of theta, adjacent over hypotenuse. And tangent theta, opposite over adjacent. And if you recall, we always use these with right triangles, which we happen to have two special ones that we've just looked at. What did we use to remember those equations? It was SOHCAHTOA. Why SOHCAHTOA? If you take the first letter of each word in each equation, sine opposite hypotenuse, you get SO. Cosine adjacent hypotenuse, you get CA. Tangent opposite adjacent, you get TOA. So these are the tools we're going to be using. And what we're going to be using it for is to find some special trig values. Ones that actually correspond with these triangles. So, first off, we're dealing with 45 degrees. So, I'm going to draw a 45 degree angle in standard position. Let's try that again. Okay, my 45 degree angle. Now, in order to use any kind of trig with this, I need to actually convert this into a triangle. So, if I convert it into my triangle there, just connect down to the x-axis, I'll have my right angle in that corner. And this is actually one of the special triangles. It's the 45, 45, 90. So I automatically know the sides. I know that my two legs are x, and the hypotenuse is x root 2. Doing this, now I have all the information I need to find what sine, cosine, and tangent of 45 degrees are. Sine is opposite over hypotenuse. The opposite side, our angle, always going to be the one by the origin, always going to be the one in the middle. So the opposite is this side that I just underlined in yellow. Hypotenuse, right there. So sine of 45 is x over x root 2. Now, with all of these, we'll be able to do some simplifying. We've got an x on the top and an x on the bottom that can cancel each other out. So sine of 45 is actually 1 over root 2. Biggest problem with this is that we're not allowed to leave root signs in the bottom. So, to get rid of that root sign in the bottom, we need to multiply by root 2 on the top and the bottom. On the top, 1 times root 2 is root 2. On the bottom, root 2 times root 2, root 4. But root 4 is actually 2. There we go, sine of 45 degrees. If we turn into cosine, well, cosine, ka, is adjacent over the hypotenuse. Hypotenuse, again, x root 2. Adjacent is that bottom side, the x. So, cosine of 45 is x over x root 2. Trying to make that x look a little nicer. Leaves us in the same boat we were in with sine of 45. So in the interest of saving a little bit of time, since we've already done the math once, cosine of 45 is root 2 over 2 as well. Last one is tangent. Tangent 45, well, we take a look. Tangent is TOA. Opposite over adjacent. Opposite is that x. Adjacent is that x. So tangent 45, x over x. X over x simplifies just to 1, so tangent of 45 is 1. And just like that, we've got the 3 primary trig functions of 45 degrees. Sine 45, cos 45, and tan 45. It's going to look roughly the same when we deal with 120 degrees. We still need to draw out that angle in standard position. $120, roughly there. Now, it might be unclear where to connect this to make the triangle, because we can't just go back to the initial side there. when we make these triangles, we're always going to connect them down to the x-axis. So right now we've got a 30, 60, 90 triangle here. We need to take a look at the sides. Short side is along the bottom. It's x. Hypotenuse, 2x. And the long leg is x root 3. Now, since we are on an xy axis, we do need to take into account negatives when they come about. So the x, since it's to the left on the x-axis, should actually be negative x. The x root 3 will stay positive because it's going up. The 2x will also stay positive because it's not actually on an axis one way or the other. The hypotenuse can't actually be positive or negative, so we just leave it positive. So now we start looking at the trig functions. Sine of 120 degrees. Sine again, opposite over the hypotenuse. Which angle are we looking from? This one in here by the origin, by the middle. Opposite, x root 3. Hypotenuse, 2x. So the sine of 120 is x root 3 over 2x. Cancel the x's, top and bottom. Oh, sorry. No, never mind. Never mind. Sine of 120 is root 3 over 2. Perfectly fine to leave it like this. Root sine's in the top. Move on to cosine. Cosine of 120, cosine's adjacent over the hypotenuse, negative x and 2x. Cancel the x's. Cosine of 120 is negative half. Finally, moving on to tangent. Tangent being opposite over adjacent, opposite x root 3, adjacent negative x. Cancel some x's. So tangent 120, root 3 over negative 1. But that's messy. Putting a divide by negative 1 just isn't common practice. So tangent 120 is negative root 3. Each one of the questions like this will proceed in a very similar manner. Draw out the special triangle, determine whether it's a 45-45 or a 30-60. Label the sides, use SOHCAHTOA, simplify. And that's really all that there is to it.